So now let us start with the first question. This was asked in JEE Mains 2023. Let A be the point 1, 2 and B be any point on the curve x square plus y square is equals to 16. If the center of locus of point P, which divides the line segment AB in the ratio 3:2, is the point C alpha comma beta, then the length of line segment AC is. So basically, what are they telling us? That there are 2 points. One is A, which is 1, 2, and there is another point B, and we have to find out first the locus of point P, which divides AB in the ratio 3:2. Once we found out the locus of point P, we have to find out its center. So now in the question they've given us a hint here. They've told us that the center of locus of point P. That means from here you can at least have gotten an idea that the locus of point P wouldn't be a straight line, wouldn't be a pair of straight lines. It would either be a circle, it would either be a parabola, ellipse or hyperbola, because all these conics only have centers in them. So it can be either of these. And once we found out the center, since we know alpha comma beta, then we can simply find out A and C. So first let us draw the diagram of this entire thing that has been told to us. This is our circle, again the standard form of the circle, where the center is at 0, 0. There is one point A which is 1, 2. Now let's say if I was to take out this curve, which is x square plus y square minus 16, and if I find out S1 with respect to A, what is it going to be? S1 for A point, which is 1, 2. What is it going to be? 1 plus 4, which is 5 minus, so it's going to be minus 11, which is less than 0. That means the point lies inside the circle. Point A would be lying somewhere here, 1, 2. And let us assume there is another point B. Since B lies on the circle, so we can assume it to be in its parametric form, which is r cos theta comma r sin theta. And what is our r here? Since it is 16, that means it becomes 4. So it becomes 4 cos theta comma 4 sin theta. Now they've told us that there is a point P which divides A and B in the ratio 3:2. So let us assume we have to find out the locus of P basically. So let us assume P to be h comma k. I hope you all remember we had studied this in straight line, that if we have to find out locus of any point, we assume it to be h comma k, and later once we've found out the equation which is only based on h and k, we replace h by x and k by y, we get our locus. So let's do that same thing here. This is our straight line. Here we have A, which is 1, 2, and here we have B, which is 4 cos theta comma 4 sin theta. And somewhere here we have our P, which is h comma k, and it divides the line AB in the ratio 3:2. So now let us use our section and midpoint formula to first find out h. What would h become? It would become 12 cos theta plus 2 by 5, and our k would become 12 sin theta plus 4 by 5. So we've gotten our h and k. Now we can see that cos theta and sin theta are there in both these terms. So we can use our trigonometric equation, which used to be cos square theta plus sin square theta is equals to 1. So let us find out the values of cos theta and sin theta. So what is cos theta going to be? 5h minus 2 by 12, and sin theta is going to be 5k minus 4 by 12. So let us now square and equate these equations to 1. So what do we get? 5h minus 2 by 12 whole square plus 5k minus 4 by 12 whole square is equals to 1. So by just looking at this equation, I hope you all must have understood or have gotten the idea that this is none other than the equation of a circle. So first let us replace our h with x and k with y. So what do we get by doing that? And let us cross multiply 12. What do we get? We get 5x minus 2 whole square plus 5y minus 4 whole square is equals to 144. And let us make the coefficient of x and y 1, so that we will get this in our complete standard form of a circle. So what would this become? X minus 2 by 5 whole square plus y minus 4 by 5 whole square, and this is equal to 144 by 25, because I've taken 5 common from both these terms, and of course since it was square, so it becomes 25. Or rather, let us write this down in this format. This becomes 12 by 5 whole square. So we've gotten this in our standard form, which was x minus h whole square plus y minus k whole square is equals to r square, where our h and k was used to be our center, h comma k. So what do we get from this equation? We get our centers to be 2 comma 5, 2 by 5 comma 5 by 4. So we've gotten our center. And in the question they had told us that the center is the point C, alpha comma beta. So that means we've gotten C. So that means we've gotten C, which is nothing but 2 by 5 comma 4 by 5. Now we have what has been asked to us in the question. We have to find out the length of line segment AC. So AC, of course the distance, we have to use our distance formula. A point is 1, so 1 minus 2 by 5 whole square plus 2 minus 4 by 5 whole square, and this would be our answer. So let us try to solve this. We get 3, which makes it 9 by 25 plus 636 by 25, and from here we get root under 45 by 25. So let us cancel out 5 5s are 5 9s are, so we get 3 by root 5 as our answer, and this is our length of line segment AC. So again, this question was fairly, I would say, simple. The only thing is about the concepts of circle that you must understand. A few locus concepts that you had to remember. That was all. Let us look at the other question. This question was again asked in 2023, but on another shift. The points of intersection of the line ax plus by is equals to 0 and the circle x square plus y square minus 2x is equals to 0 are A and B. The image of circle with AB as a diameter in the line x plus y plus 2 is equals to 0 is. So what do we have to find out? See, first of all, we have been provided with a circle and they have told us that the circle is intersected by a line at 2 points A and B. They have given us the points as well. Now we have to find out first a circle which is on AB as a diameter. So it would be somewhat like this. And once we found out that circle, we have to simply just take the mirror image of that circle in this line, x plus y plus 2 is equals to 0. So again, very easy questions. So let us do that. This is our circle that has been given to us. What is the center of our circle? It is of course minus g comma minus f. So f is our 0 since there is no y term in this equation. X square plus y square minus 2x is equals to 0. And what is our g? G is nothing but minus 1. So minus g becomes 1. So our center is 1 comma 0. And what have they told us? That there is a line. This is our ax plus by is equals to 0. And this intersects the circle at 2 points A and B. So let us try to find out what our A and B would be. Of course, since A is a point alpha comma 0, this lies in this circle. So it would satisfy the equation of the circle as well. So for A alpha comma 0, we can say that this would, for this S1 would be equal to 0 since it lies in the circle. And what is our S? S for this circle is x square plus y square minus 2x. That's it. So our S1 would become alpha square plus 0 minus 2 alpha. This is equal to 0 if A point is lying in the circle, and they have told us that A and B are lying in the circle because they are the points of intersection. So from here what do we get? Alpha minus 2 is equals to 0. So either alpha is equal to 0 or alpha is equal to 2. So we've gotten two values here of alpha and beta. Sorry, of alpha. Now which one do we have to take? Since we know that A alpha comma 0 also lies in the straight line as well. Straight line as well. So that means A alpha comma 0 for L1 would also be 0 because it is lying in the straight line as well. And what is our L? L is nothing but ax plus by. So let us put L1 in this equation. What do we get? a alpha plus by. Y is 0, so plus 0 is equals to 0. And from here, what do we get our alpha to be? 0. That means our alpha is 0 and we reject 2. So we've gotten our first point A, which is 0, 0. Now let us find out B. Again, B is another point which lies on the circle. So B would be satisfying the equation of the circle. So let us do that. For B, 1, beta, let us satisfy directly it in the circle. We get 1 plus beta square minus 2 is equals to 0. So from here we get beta square to be equal to 2 minus 1, which makes it 1. So beta is equal to 1 plus minus 1 basically. Now of course, which is the value that we are going to take? Let us satisfy beta in the straight line as well. So what are we going to get? A plus b beta is equals to 0. So from here we can say that beta would be equal to minus a by b. And here, so still by looking at this and this equation, beta is equals to plus minus 1, we cannot make out whether beta is either plus 1 or beta is either minus 1. So let us try to find something else about beta so that we can estimate whether beta is plus 1 or minus 1. Now what else has been given to us in the question? Look for information. They have told us that A is not equal to B. That means if A is not equal to B, that means this value would never cancel out amongst each other. And if this value is never getting cancelled out amongst each other, that means beta would never be equal to either minus 1 or plus 1. If let's say if A is equal to B, then A and B would be cancelled out amongst each other and we would simply get minus 1 as our beta. If A and B are not equal to each other, let's say they are some other values, that means we can neither get 1, we can neither get minus 1. However, if A is equal to minus B, this one also satisfies this equation, and this one, if we apply this here, instead of B, if I write minus A here, A and A would get cancelled, minus and minus would get cancelled, we would get beta to be plus 1. So that means we've cracked this part of our equation. A is equal to minus B, that means beta would come out to be 1. So we've got our second point as well, which is 1, 1. Now they have told us that the image of the circle with AB as a diameter. So we know A and B is the diameter. So let us find out the equation of a circle where AB is the diameter. So how do we do that? Our A point is 0, 0 and our B point is 1, 1. So if I take these 2 points as my diameter, what is my equation of circle going to be? X minus 0 into x minus 1 plus y minus 0 into y minus 1 is equals to 0. This was the formula of diametric form that we had studied. So from here, what do we get? We get x square minus x plus y square minus y is equals to 0. So x square plus y square minus x minus y is equals to 0. So this is my circle with AB as diameter. Now what is the center of this circle? The center of this circle is nothing but 1 by 2, 1 by 2. I hope you are understanding. Minus 1 is our 2g. So what do we get our center? Center used to be minus g, minus f. So from there we get half, half. And what is our radius? Radius used to be g square plus f square minus c whole root under. So root under g square plus f square minus c is 0. So we get 1 by 2 root 2 to be our radius. So from here, we've gotten all the details about the circle that we have to find out. Now we have to find out the image of this circle in this line. What is this line? X plus y plus 2 is equals to 0. So we have the equation of line. So I hope you all remember, if this used to be the line where we are finding out the image, and this is our circle, then the image would have the same radius, and the only difference here is that the center would be the image of this point. That means this distance is equal to this distance. So I hope you all remember, we had studied in straight line the point, the image of a point on a line formula. So let us apply that here. It used to be x minus x1 by a is equals to y minus y1 by b, and this is equal to minus 2 ax1 plus by1 plus c upon a square plus b square. So let us use this formula with the center. Center is half comma half, so we get x minus half. A is our 1, this is equal to y minus half. B is also 1, minus 2 times of ax1 plus by1. So half plus half makes it 1, 1 plus 2 makes it 3 upon a square plus b square. So this becomes 2. 2 and 2 gets cancelled. So what do we get x to be? X is our minus 3 plus half, and y is our minus 3 plus half. So our center of this image circle comes out to be C dash. Let us call this as C dash. C dash comes out to be minus 5 by 2 comma minus 5 by 2. So this is our center. And what had they asked us? The image of the circle with AB. So basically we have to find out the equation of this image circle. So what is our equation going to be? X plus 5 by 2 whole square plus y plus 5 by 2 whole square is equals to r square, and radius of the image and the original circle remains same. So this would be 1 by 2 root 2 whole square. So this is our answer. Again, a very easy question. They had used the concept of image of a circle in this question. The only thing is that you had to identify this information that they had provided us, where a is not equal to b. And if a is not equal to b, then from the values of beta that you had gotten, plus minus 1, you had to calculate, or you had to logically find out this value, that a can be equal to minus b. If a is equal to minus b, then all our equations get satisfied. So that was the catch that you had to find out in this equation. Rest everything was very conceptual based and formula based. Let us move to the next question. Now let us look at this question. The locus of the midpoints of the chords of the circle C1 is which subtend an angle theta I at the center of the circle C1 is a circle of radius Ri. If theta 1 is this, theta 3 is this, and r1 square plus is equals to r2 square plus r3 square, then theta 2 is equal to. So basically, first let us draw the diagram of the circle and the information that they've provided us. I think from there, more or less our solution would be solved automatically, and we would know exactly what we have to find out. So this is our circle. This is the circle they have provided us. They have told us that the center is 4,5 and the radius is 2 from this equation. I hope you all are able to find out that this is the standard form that we had studied. And from the standard form we know how to find out the center and radius. Now they have told us that there are a lot of chords in this circle. Let's say this one or anywhere. So these chords subtend an angle theta I. So let us say for the timing that they are subtending an angle theta at the center. Let's say this angle that they've subtended is theta. And they've told us that the locus of midpoints of these chords. So let's say this is our midpoint P, and let us assume this to be h comma k. So basically we have to find out the locus of h comma k. So of point P, which is the midpoint of the chord. So let us assume it to be h comma k. Let us join this line. Of course, I hope you all remember that we had studied this in chord, that this, if the center, from the center to the midpoint I draw a line on the chord, then it would be perpendicular to the chord, as well as it would divide the chord into equal halves, and the angle would also be divided into equal. So this would become theta by 2, this would also become theta by 2. So this length here, the hypotenuse, we know it is 2 because it is the radius. So from here, what can we tell about using the Pythagoras theorem? We can say that cos theta by 2 is base by hypotenuse. And what is our base? Our base is P to the center. Let's say our center is C. So it is P to C by hypotenuse, which is our 2. Let us say that P to C, this distance is our D. So let us write it down in this format. This would be equal to D by 2. So what do we get our D to be from here? 2 cos theta by 2. Now we've gotten this length. Now what have they told us? that the locus of midpoints of the chords of the circle subtend an angle at the center of the circle. The locus of P point is also a circle with radius Ri. So they've told us that this also would automatically turn into a circle, and this circle would have the radius Ri. So basically they have told us that D is nothing but D is our Ri, which is 2 cos theta by 2. I hope you all are understanding this point. They have told us that the locus of midpoints of the chords is a circle of radius Ri. Let us exclude this portion for the time being. They have told us that the locus of midpoints of the chords is a circle of radius Ri. So what is our locus of midpoint of chord? That is our point P, and each and every chord would be lying, of course, inside the circle. So the circle of Ri radius would be lying inside the circle as well, and their center would again be nothing but 4,5, and this distance D that we just called out, that would be our Ri radius. So now once we found out Ri, they've given us a lot of information in the question. They've told us that theta 1 is equal to pi by 3. They've told us that theta 3 is equal to 2 pi by 3. So now we can use this formula. Ri is equal to 2 cos theta by 2. So let us find out R1. This would be, of course, with theta 1. So 2 cos pi by 3 by 3 into 2. So from here we get 2 cos pi by 6, which is our root 3. And similarly we can find out R2 as well. It would be 2 cos pi by 3, and this comes out to be 1. So we've gotten R1, and sorry, this is not R2, this is R3. They've given us theta 3. So we've gotten R1, we've gotten R3. Now we have to find out R2. They've given us this equation in the question about R2, where R1 square is equal to R2 square plus R3 square. Sorry, this is not cube, this is square. So what is our R1? R1 is root 3. So this becomes 3 is equals to R2 square plus what is our R3? 1. So it remains 1. So R2 becomes root 2. So once we've known that R2 is root 2, again we can use this formula, which is Ri is equals to 2 cos theta by 2. Again, theta can be written as theta I as well. So we can write it down in this format, that R2 would be equal to 2 cos theta 2 by 2. We have to find out theta 2, right? So R2 is root 2. So this becomes 1 by root 2 cos theta 2 by 2. And from here what are we going to get? This would be basically cos pi by 4 is 1 by root 2. So we can say cos pi by 4 is equals to cos theta 2 by 2. That means theta 2 by 2 is equals to pi by 4. Theta 2 comes out to be pi by 2. So this is our answer. Again, a very simple question. The only thing is that you had to understand what circle and what locus they are talking about. So if you would have been able to find out this circle, that the D, the distance from the center to the point P is only our Ri, then the entire question is very simple here. So now let's look into another question. Now let us look at this question. In the circle given below, let OA is equals to 1 unit, OB is equals to 13 unit, and PQ is perpendicular to OB. Then the area of triangle PQB is. So basically we have to find out the area of this triangle here. So let us first look at the scenario and to what are the information that has been provided to us in the question. They have told us that OA is 1 unit. That means this here is 1. And OB is 13. That means if OB is 13, that means we can say that AB would be 12. So we can write it this way. And they have told us that PQ is perpendicular to OB. First of all, we know that OB is one of the diameters. And why is OB a diameter? Because the circle is touching the y-axis. If the circle is touching the y-axis, that means the center would be lying somewhere here in the x-axis. That means OB becomes our diameter. So our diameter is OB. And if OB is our diameter, that means, and PQ is perpendicular to OB, that means this length would be equal AP, we can say that AP is equal to AQ, and let us say that this is some random variable lambda. Let us assume this is our lambda. So we can assume it in this way. Now, I hope you all remember, if there is a circle and there are two lines passing in a circle, then let's say if this is point A, this is B, O, P and Q, then this used to be a geometrical property of a circle, that AB into OA is equal to PA into PQ. If there are two lines inside a circle that intersect each other at a point at 90 degrees, then we can say that from the point that they intersect, all the product of all four sides would be equal. So that is exactly what we've written. So for one line, AB into AO is equal to AP into AQ. Sorry, this wouldn't be PQ, this would be AQ. So now we've assumed that our AP and AQ are lambda. So let us put those values and find out the value of lambda. Once we've found out the value of lambda, then we can see that this entire triangle, whose area we had to found, has been divided into two equal right angle triangles, where we know the value of our height, which is 12, where we know the value of our base, which is lambda. Simply we can use our half into base into height formula once we found out lambda as well, and then we can multiply it by 2, and that would be our area of the triangle. So let us do that. Let us put the values here. AB, which is our 12, into OA, which is our 1, PA is lambda, and AQ is also lambda. So from here what do we get? Lambda is equals to root under 12. So basically, let's say if this is our triangle, this is our right angle, this is 12, this is root under 12. So let us find out the area of this triangle. What can we say about the area? Half into base into height. So from here we get 6 root 12. And since there are two similar triangles whose area we need to find out, so our total area of triangle PQB would be equal to 12 root 12. We've multiplied it by 2. PQB, we've got it 12 root 12. Or this can also be written in this form, 24 root 3. So this is our answer. Again, a very easy question. The only thing that you had to know here is that the property of this circle, if there are two lines inside a circle which intersect at a point and they are at 90 degrees to each other, then that means they are in this format, then we can say that AB into AO would be equal to AP into AQ. So that is the exact same property that we've used, and we've gotten our answer. Let us look at the next question. Now let us look at this question. The sum of the squares of the lengths of chords intercepted on the circle x square plus y square is equals to 16 by the lines x plus y is equals to n, where n belongs to natural numbers, is. So basically, as we change the values of n, of course, our chords, our equation of chords would change. That means our chords are changing, and as our chords are changing, the length of the chord would also change. So if the length of chords are changing, so we have to find out the sum of all those squares. So first, let us draw our circle. Again, this is a standard circle which has its center at 0, 0, and the radius is 4. Now they've told us, let us take any one of the chords. Let us remove these lines. We've gotten our chord. Let us join it with the center. So how can we find out the length of this chord? So basically, of course, it is very easy for us to find out the length of chord. Had they provided us with any information such as the midpoint or anything, it would have been very easy for us by simply finding out root S1. However, we do not have that, so let us simply uh, try to find out it in some other way. This value we know is 4. If we can find out this perpendicular distance, since we know the equation of this line is x plus y is equals to n, if we can find out this perpendicular distance, which is d, if we found out d, then using Pythagoras theorem we would be able to find out this. Let us say this is our L, and since we know that a perpendicular from the center of circle on any chord divides that chord into two equal parts, so this would also become our L. So 2L becomes our length of chord. So our length of chord is 2L. So from here let us find out L, and once we found out our length of chord, then we can find out the sum of squares by changing the values of n. So let us do that first. Let us first find out d. D, again we can find it out by the perpendicular distance. What is our L here? Our L here is x plus y minus n. Let us put 0 comma 0 in this equation. We get upon root under 2. So d is our minus n mod by root 2, and since n is our natural numbers, so n can never be negative, so we can simply remove this modulus sign, so it becomes n by root 2. And from here, using Pythagoras theorem in this triangle, what do we get? 4 square is equal to d square plus l square. So from here, what do we get? L square is equal to 4 square 16 minus d square, which is our n square by 2. So from here, what do we get? Our L to be root under 16 minus n square by 2. And what does our length of the chord finally become? Which was 2L, so it becomes 2 times root under 16 minus n square by 2. Sorry, this is just under n square. So from here, first things first, what is the values of n that we can justify? We can see that n lies inside the square root, n square, and any value inside the square root of course cannot be negative. We had studied this in functions, range and all those things. So we have to say that 16 minus n square by 2 has to be greater than or equal to 0 at all times. So from here, what can we say? That n square by 2 is less than equal to 16, or n square is less than equal to 32, n is less than equal to root under 32, and root under 32 can be written as root 32 can be written as we can write this down as 4 into 4 into 2, so this becomes 4 root 2. So from here, we found out one of the values of n. So we know that n is always less than or equal to 4 root 2. And what is 4 root 2 approximately? It is somewhat greater than 5, of course. 4, let us assume that our root 2 is 1.414, and if we multiply this by 4, what are we going to get? 5 point something something. So if we are getting 5 point something, that means our n is always less than 5 point something. That means possible values of n comes out to be 1. Since n is a natural number, so of course 0 cannot be one of them. So 1, 2, 3, 3, 4 and 5. Of course, all these 5 values are those values of n which satisfy our equation. So now simply what have they asked us? They have asked us to find out the sum of squares of their lengths. So the length of chord is 2 root under 16 minus n square by 2. So L square, Li square, or let us write it down in this way, or let us write this down as LCI square. So this is our length of chord whole square. This becomes 4 times of 16 minus n square by 2. So now let us one by one put the values of n from 1 to 5 in this equation and find out our answer. So this would turn out to be 14 times of 32 minus 1 by 2 plus 4 times of 32 minus 4 by 2 plus 4 times of 32 minus 9 by 2 plus 4 times of 32 minus 16 by 2 plus 4 times of 32 minus 25 by 2. So from here 4 by 2 can be taken common, so we've taken 2 common here. What are we getting? 31 plus 28 plus 23 plus 16 plus 7, and from here what are we going to get our answer to be? 210. So this is our answer. Again, the only major part that you had to remind yourself about in this question was that any perpendicular on a chord from the center of the circle divides that chord into 2 equal parts. So, and once we found out the length using the distance for first the distance formula and then the Pythagoras theorem, then our solution becomes very easy. We understand that inside the square root there cannot be a negative value, so always we had to apply this condition here, which is 16 minus n square by 2 is greater than equal to 0, and from there we got certain values of n which satisfy our equation, and then by putting those values into our answer we've got our final answer, which is the sum of squares of length of chords. Let us look at another question now. In this question, they have told us, let a circle passing through 2, 0 have its center at the point h, k. Let xc, yc be the point of intersection of the lines this and this. If h is limit c tending to 1 xc and k is limit yc, then the equation of the circle is. So basically we have to find out the equation of circle which has its center at h, k, and there is a point on the circle which is 2, 0, and they have told us that there is a point. These are of course two straight lines here they have given to us, and the point of their intersection is xc, yc. So let us first try to find out information about xc and yc. So they've given us two lines, 3x plus 5y is equals to 1, and the other one is 2 plus cx plus 5c square y is equals to 1. So what we can do is, let us take any one value from this equation and try to put it on the other, and then let us try to find out the value of x and y. So from here what can we say? Y is equal to 1 minus 3x by 5. So let us put this value here. What do we get? 2 plus cx plus 5c square, 1 minus 3x by 5 is equals to 1. So 5 and 5 can get cancelled. 2 plus cx plus c square minus 3c square x is equals to 1. From here what are we ultimately getting? Our value of x to be, our x would become 1 minus c square upon 2 plus c minus 3c square. Yes, so we can take of course x common from these two terms, and what are we going to get after taking common inside the bracket? 2 plus c minus 3c square. We've taken our 1 c square on the other side, so we've gotten our x to be this. And what is our y? So this is our xc basically, and our yc is 1 minus 3x by 5. So we can say it is 1 minus 3 times of 1 minus c square upon 2 plus c minus 3c square upon 5. So what are we going to get our yc to be equal to? I'm just writing down the values straight away. You can simply calculate it by multiplying 3 inside, then taking LCM and then multiplying it by 5 as well. So our yc comes out to be c minus 1 upon 5 times of 2 plus c plus minus 3c square. Basically our main motive is to understand the concept and not the calculations. So we've gotten our yc as well. Now what have they told us? That again, this point has no direct relation to the circle that we are trying to find out. However, they have told us that the center of circles somehow rely on these points, which is our xc and yc. They've told us that h is equal to limit c tending to 1 xc. So from here we can say that limit c tending to 1, what is our xc? Xc we've just found out, that is 1 minus c square upon 2 plus c minus 3c square. So first let us put the value of 1 in this equation. What are we going to get? We are getting 0 by 0. So this becomes a 0 by 0, of course, indefinite form. So let us try to simplify this. What can we do here is that we can take c tending to 1, or simply let us just differentiate both the numerator and denominator, like the way we had studied in limits when we were studying that chapter. If it is an indefinite form or indeterminate form, we can simply differentiate the numerator separately and the denominator separately. So what are we going to get? Minus 2c here upon, this would get cancelled, this would be 1 minus 6c. So from here, now if I put the value of c to be 1, what am I going to get? Minus 2 by 1 minus 6, which makes it minus 5. So I am getting 2 by 5 to be my h. So my h is 2 by 5. I've got the first coordinate of my center of circle. Now let us find out the other. K was also equal to limit c tending to 1 yc. Now let us put the value of yc in terms of c that we just found out. It is c minus 1 upon 5 times of 2 plus c minus 3c square. Again, if you put the value of c directly, this becomes a 0 by 0 indeterminate form. So let us differentiate the equation. What are we going to get? It would be 1 on top, and below we would have 5 times of 1 minus 6c. Now let us put the value of c to be 1. What are we getting? 1 upon minus 25. So our k becomes minus 1 by 25. So this is our other portion of the center. That means our circle's center we've found out, which is h comma k. So it is 2 by 5 comma minus 1 by 25. So this was told to us that the center is h comma k. Now we have to find out the equation of the circle. So now of course it becomes very easy for us, since we know the center and we know there is a point that is on the circumference of the circle. Let a circle passing through 2 comma 0. That means our circle, we've got our center, which is h comma k, and there is a point 2 comma 0 in this circle. So by using distance formula, I can find out the radius of this circle. The distance that I find out between these 2 points, that would be nothing but my radius. So let us find out the radius in that format. So my radius would be root under 2 minus 2 by 5 whole square plus, it is 2 comma 0, so 0 plus 1 by 25 whole square. So from here, what do I find my radius to be? 5 2s are 10, 10 minus 2 becomes 8 by 5 whole square plus 1 by 25 whole square. So from here, what is my final result that I'm going to get? 1601 upon 625. So this is my radius, or I can simplify this to 1601 by 25 as well. So this is my radius. Now we have to find out the equation of the circle. We know the center, we know the radius. Simply we can write it down in our standard format. So x minus 2 by 5 whole square plus y plus 1 by 25 whole square is equals to 1601 by 625. Simply r square can be written in this format. So this is our answer. This is the equation of the circle that I was trying to find out. Now again, this was a very good question. The first thing that should have struck your mind while looking at this question is that they have given us limit c tending to 1 xc and c tending to 1 yc. That means you have to convert xc and yc in such a way that they are only in terms of c, and by using this limits where c is tending to 1, you can find out the value of h and k. So that was the only concept here that you had to understand. So, and we did that very easily by just substituting the value of y from one of the straight line equations into the other, and from there we found out our xc and yc in the forms of in terms of c, and then by using the limits we got our h and k, and then the entire question was very simple. Now let us look at another question. In this question, let the circles C1 x minus alpha whole square plus y minus beta whole square is equals to r1 square, and C2 is x minus 8 whole square plus y minus 15 by 2 whole square is equals to r2 square. So in both these circle equations, they haven't provided us with the radius, and in one of the circles they haven't provided us with the center as well. It is alpha and beta. Now they've told us that these two circles touch each other externally at the point 6, 6. If the point 6, 6 divides the line segment joining the centers of the circles C1 and C2 internally in the ratio 2:1, then alpha plus beta plus, so we have to find out basically our alpha and beta and R1 and R2. So let us draw the diagram of the things that they have told us. They've told us that there are two circles. Let us say this is my C1, this is my C2. My C2 circle has its center at 8, 15 by 2. They are touching each other externally. That means this point here is my 6, 6, or let me write this down in a better way. So these are my two circles. This point becomes 6, 6, and they've told us that this center here is alpha, beta. This of course would be my R1, and this length here would be my R2. And they've told us that this point divides this line segment in the ratio 2:1. So basically what do we know from here is that this is my point alpha, beta. This is, let's say, my point P, which is my 6, 6, and this is my another point C2, this is C1, which is 8, 15 by 2. So by using again the section midpoint section formula that we had studied in straight line, we can find out using this ratio and the mid and the point in between, we can find out the values of alpha and beta. So once we found out alpha and beta, of course we can use the distance formula between the centers of the circle and 6, 6. We would be able to find out our radiuses as well. So let us use our section formula. What do we get? 6 would be equal to alpha plus 16 upon 3, and 6 would be equal to beta plus 2 times of 15 by 2. We get 15 by 3. So from here what do we get our alpha to be? 6 3 is 18, 18 minus 16, alpha becomes 2 and beta becomes 3. So we've gotten our alpha and beta. So first part of the question is done, where we've gotten our alpha and beta. Now we have to find out our radius. So this point here is 2, 3. Now let us find out the radius. Again, R1 can be said to be the distance from, what is our center, 2, 3 to 6, 6, which is our external point at which it is touching. So this is, again, by simply using the distance formula that we've studied, 6 minus 2 becomes 4 square, 16 plus 3, 9. So this becomes 5. Our R1 is 5. And what would our R2 become? R2 would be distance from 8, 15 by 2 to 6, 6. So this would become 2 square, which would become 4 plus 15 by 2 minus 6 whole square. So let us try to solve this. We get 4 plus 15 by 2 minus 6, this becomes 3 by 2, so which makes it 9 by 4. So ultimately this comes out to be 4, 16, 25, so we get 5 by 2 as our R2. Now what was asked to us in the question? We had to find out alpha plus beta plus 4 times of R1 square plus R2 square. Now simply we can just put the values of alpha and beta in R1 and R2 and find out our answer. Alpha and beta is 2 and 3, which makes it 5, plus 4 times of R1 square makes it 25, R2 square makes it 25 by 4, and from here what do we get our answer to be? 130. So this is our answer. Again, a very easy question. The only thing is, once you draw the diagram of this question, the entire question is solved there and there itself. You can see that there is the external point has been given to you. You can use the section formula to find out the other center, which is alpha comma beta, and once you found out the other center as well, you can simply find out the radiuses by using the distance formula between that external point and the center of the circle. Now let us look at another question. In this question, they've given us that let C be a circle with radius root 10 units and center at the origin. Let the line x plus y is equals to 2 intersect the circle C at points P and Q. Let Mn be a chord of C of length 2 unit and slope -1. Then a distance between the chord PQ and the chord Mn is. So basically, let us first draw the diagram. They've told us that this is a circle. They've told us that the center is at origin. The radius is root 10 units, so our R is root 10. And they've told us that there is a chord Mn. Let's say this is our chord. This is our M point. This is our N point. Sorry, this is our N point. The length of this chord is of course 2 units. So whenever the center of the circle is given, let us first drop the perpendicular. Of course, this and this becomes equal, which is of 1 and 1 units. We know our radius, which is root 10. Now what have they told us? That we have to find out the distance between another line, which is also a chord of this circle. Now what can we understand about this chord? They've given us the equation x plus y is equals to 2. Now first of all, we do not know what type of chord our Mn is. We do not know any information about it. We only know that its slope is -1. That is why we drew the line in this manner, in this slant way, because this has slope is equal to -1. Apart from this, we do not have any information about Mn. That means Mn might be can lie at any point in this circle. It can lie here as well, it can lie here as well, or it can lie anywhere on the circle. Now PQ line is fixed, of course. It is somewhere either here or here. So what can we tell about the distance between PQ and Mn? Of course, PQ and Mn, both these lines have slope -1. That means they are parallel to each other. So what we can do is, let us first find out the distance from the origin of both these lines. Once we found out that, of course, either the sum of those two distance would be our answer, or the subtraction of those two distances would be our answer. So first, let us find out this distance. This is our D. D would be calculated using our Pythagoras theorem. So we can say that root 10 whole square would be equal to 1 square plus D square, and from here we get our D to be 3. So this is our 3. D is 3. So we've got the distance of Mn line from the origin. So it is always going to be 3. So either this line can lie here or this line can lie here, where again the perpendicular distance is 3. So there can be two places where Mn can lie. Of course, the slope is -1, so there can be only two. Had they not provided us with the slope, we would have said that there can be two more ways how Mn could have lied. Now PQ is a fixed line. So since PQ is a fixed line, its equation is x plus y minus 2. Let us find out the distance of origin from PQ. Let us find out the distance of origin from PQ. What do we get? Origin to PQ, perpendicular distance. This can be written as, again, using this formula of the distance of a point from a straight line. We can say that this would become 0, x plus y minus 2. So the 0 minus 2 upon root under 2. So from here we get this would become plus 2, of course, because modulus is there. So this becomes root 2. So our distance of PQ from the origin is root 2. That means PQ is lying somewhere here. Root 2. Now, of course, PQ is a fixed line. We have been provided with PQ. So basically, what are the values known to us? Let's say if this is our circle, this is our coordinate axis. Somewhere here our PQ is lying. We know that MN can either be here because the distance of MN is 3. So the distance can remain constant, or MN may lie here. I hope you are understanding this thing. We know that MN is at a distance of 3 units from the origin. And we know that PQ is at a distance of root 2 units from the origin. So what can be our answers from this? We can say that the distance between PQ and MN would be two values. One would be, let's say, if I take this line and this line, and once it can be if I take PQ and this line. So it can be either 3 plus root 2 or it can be 3 minus root 2. So again, this was a multiple choice question and we've gotten our answers. Of course, in JEE Mains you do not have to select multiple options, you just have to select a single option. So they had given us in the question that one of the options was 3 plus minus root 2. So you had to select that option basically. This becomes our answer. So again, in this question, the major thing here was that you had to find out the distance of MN from the origin. And once you found out the distance of MN from the origin, you must have understood that there can be only two possibilities for MN to lie in this circle. Of course, PQ line is fixed. It cannot be changed. Its distance is root 2 and it is just one line. It will remain the same because the constant term for this line has also been provided. Once you found out those distances, you would have, of course, tried to justify using this type of diagram that PQ can lie either in front of MN or at the back side of MN. So from there, you had to find out these distances. So that is how this question is done. Let's move on to the next question. In this question, they have given us if a point P has coordinates 0, -2 and Q is any point on this circle, then the maximum value of PQ is. Again, this is the most easiest question and a question which requires zero knowledge of any concepts or anything. The only thing that you had to remember here is the parametric form of the circle. So again, Q is any point on the circle. So our circle is x square plus y square minus 5x minus y plus 5 is equals to 0. So our center for this circle becomes 5 by 2, 1 by 2. And what would our radius become? Root under g square, which is our 5 by 2 whole square. Sorry, this would become minus 5 by 2 whole square because center is minus g, plus f is square, f is our minus 1 by 2 whole square minus c. C is our 5 as given in the question. So what do we find our radius of this circle to be? It becomes root under 25 by 4. So this becomes 25 by 4 plus 1 by 4 minus 5. Or I can write this 5 down as taking 4 as the LCM. I can write this down as 20. So what do we get from here? we get our radius to be 6 by 4. So our radius is root 6 by 2. Now we know the radius of our circle, we know the center, and we know how we can write down the parametric form. Whenever a center is given for a circle, it used to be h plus r cos theta comma k plus r sin theta. So let us write that down. We get 5 by 2 plus r cos theta comma k plus r sin theta. So this is our parametric form of Q point. Now they have told us, they've asked us the maximum value of PQ. So simply we just need to use the distance formula, and they've told us to find out the square of it, the maximum square. That means the root under that used to be in the distance formula, that would simply get removed. So PQ square, let us write it down directly. I'm removing the square root from the distance formula directly. So what do we get? PQ, we are going to get 0 minus 5 by 2 minus, so this would become 0 minus 5 by 2 minus root 6 by 2 cos theta whole square, plus this would become minus 2 minus 1 by 2 minus root 6 by 2 sin theta whole square. So of course we need to find out the maximum value of this, they've told us. So somehow let's try to club cos theta and sin theta together, and then using our trigonometric inequalities that we had studied, we can find out the maximum value of this as well. So what do we get from here? Let us open both these square brackets. We are going to get 25 by 4 plus 6 by 4 cos square theta plus 2 times of 5 by 2 into root 6 by 2. So we get 5 root 6 by 2 cos theta. I'm writing things down directly. Minus 2 minus half, this would become minus 5 by 2. So of course this also becomes 25 by 4 plus 6 by 4 sin square theta, and we would get plus again 5 root 6 by 2 sin theta. So from here, let's club all these similar terms together. 25 by 4, 25 by 4, this would become 25 by 2 plus 6 by 4. Of course, if I take 6 by 4 common and I take cos square theta plus sin square theta, it would turn into 1. So I'm left with 6 by 4 plus 5 root 6 by 2. Let us take that common. What are we left with? Cos theta plus sin theta. Now, upon solving this, what are we going to get? We are going to get 56 by 4 plus 5 root 6 by 2 cos theta plus sin theta. Now, I hope you all remember we had studied in trigonometric inequalities what is the maximum value of cos theta plus sin theta. The maximum value comes at when theta is equal to 45 degree. Because I hope you all remember the graph of sine used to be in this format, the graph of cos used to be in this format, and when we are adding these two values, of course the value at the midpoint where both have the same values, this would be our maximum value for both. So at theta is equals to 45, our cos theta plus sin theta becomes maximum. Or the other way of finding this out was, you could have differentiated this. We could have assumed that our y is equal to cos theta plus sin theta, and once upon differentiating we could have equated it to 0, and upon equating it to 0 we would get our theta to be of course 45. Let us do that here. I'll show you once. D theta, this is equal to cos theta, differentiation becomes minus sin theta, and sin theta becomes cos theta, and this value if we equate it to 0, what are we getting? Sin theta equals to cos theta. And at what value does this term arrive? Of course at 45 degree. That means at 45 degree we get our cos theta plus sin theta to be maximum. So of course this concept you all can remember. Whenever you have to find out the maximum of any, let's say, value or any, let's say, equation, you can simply just differentiate it and then equate it to 0, and whatever value you get of theta or x or whatever the independent variable is, that would be your maximum value of that equation. So from here what do we get? 56 by 4 plus 5 root 6 by 2 into cos 45 plus sin 45, 1 by root 2 plus 1 by root 2, we get root 2, 2 root 2 by root 2, and from there I've cancelled it out. So from here what are we getting? 14 plus 5 root 3. This is our answer. Again, this was a very easy question. The only thing is that they had mixed the concept of trigonometry as well as we can say derivability as well, because you had to differentiate it and then find out the maximum value. So that was all. So that was all for this chapter. We've done a lot of theory concepts in this chapter. We've done a lot of previous year questions in this chapter. Now the important thing that you need to remember is that the formulas for center, the parametric equation, all these things you have to remember it by heart, because when we study conic sections in the further lectures, these things are going to come very handy for you, and doing straight lines and circles in a good manner would help you do conic sections also in a very proper way. So that was all for circles. Thank you.